another opportunity to learn chemistry again. And today, my name still remains Miss Bumi. Like you know, I'm still an educational consultant with delight in making mathematics and chemistry very easy and full of fun. So, today we'll be discussing about gas laws. You see, chemistry is the most sweetest subject I love, and gas laws should be one of the topics that you should do in tertiary institution depending on which course you're doing, and also in SS1, gas laws. Some of those gas laws are what enables us to bring out some of these formulas in chemistry, and one of the gas law is the Boyle's law. The Boyle's law. So the Boyle's law states that the pressure of a gas is inversely proportional to the volume of the gas at constant temperature. That is, the pressure of a gas is inversely proportional to the volume of a particular gas. That is, when your volume is half, therefore your pressure is also an inverse of that half, and that is twice. Yeah, when you turn your 1/2 upside down, you have 2. At constant temperature, that is, at constant temperature, no disturbance, talks about your Boyle's law. Let's move to questions on some of those Boyle's laws. Number 1, a gas has a volume of 500 centimeter cube when a pressure of 76 millimeter Hg, that Hg is mercury, is exerted on it. What will its volume be if the pressure on it is changed to 73 millimeter mercury at constant temperature? Why do I need to learn gas law? You need to learn gas law because you will need it even in domestic activities. Your petrol, you have to calculate which volume will be able to sustain at that particular pressure. And that is some of those reasons why we need to learn gas law. Now let's go to the question. Now, one of the major formula of gas law is P1V1 is equal to P2V2. P1V1 is equal to P2V2. We've been given our V1. The first volume you come across is 500 centimeter cube. The first pressure you come across is 76 millimeter mercury. The second one I came across is 73, and that gives me my P2, while my V2 is unknown. Using this formula, I have P1V1 equal to P2V2. Therefore, I have 76 times 500, give me 73 times V2. By the time you multiply everything together, we should have, and dividing by your V2, we should have 52.520 rather 0.55 centimeter cube. That leads us to take number 2. So question 2. A gas occupies 200 centimeter cube at 510 millimeter mercury. If temperature remains constant, what will its pressure be when the volume is increased to 131 centimeter cube? Still on the formula of P1V1 is equal to P2V2. So the first one I came across, my V1 is 200 centimeter cube. My P1 is 510 millimeter mercury. My V2 is 131 centimeter cube. My P2 is unknown. So I have to just use the formula. P1V1 is equal to P2V2. So I have 510 times 200, substitute everything. P2 times 131. In order not to waste our time, by the time you calculate everything, dividing and multiplication, you should have 778.63. Let's not forget the unit, millimeter mercury. Millimeter mercury. So that also leads us to number 3. I hope you enjoyed the class. Yeah. Number 3 says calculate the pressure at which the volume of oxygen is tripled if its initial volume of 3 atmosphere is 75 centimeter cube, temperature being constant. One thing I would also like to remind us is pressure is measured in 3 units. We have millimeter mercury, we have atmospheric, that's ATM, and we have in torrs. So whichever one you come across, they are still talking about pressure. Number 3 now. Number 3, my P1 is unknown. Checking through the question, and I was made to understand that my V2 is tripled. That is, my V2 is 3 times the value of my V1. So my P2 is 3 ATM. My V1, which is 3 ATM, my V1 is 75 centimeter cube. So what will my V2 be? Since my V2 is tripled of this, I should have 225 centimeter cube. Now, still on the formula of P1 V1 is equal to P2 V2. So I should have, P1 is not there, 5 is equal to 3 times 225. I should substitute everything and use my calculator. My P1 should therefore give me 9 ATM. I shouldn't, because I know that the unit of pressure is also measured in millimeter mercury, and therefore put millimeter mercury, because I know. No. The value which you are given should be the same value you should use. The same unit you were given should also be the same unit you're answering with. Is that clear? So that ends the questions on Boyle's law. I just want to make them short. So that takes us to Charles' law. So, Charles' law. Charles' law states that at constant pressure, the volume of a given mass of gas is directly proportional to the temperature of the gas at constant pressure. That leads us to some of the questions that are being asked under Charles' law, and how we will be able to identify, is it Boyle's law we're using to solve the question, or Charles' law. Charles' law talks about volume and temperature. Unlike the Boyle's law talks about pressure and volume. Number 1 question now. 400 centimeter cube of nitrogen at 30 degrees Celsius is heated at constant pressure to a temperature of 50 degrees Celsius. Find the new volume of the nitrogen. Let me also remind us that in as much as volume is a constant unit that has centimeter cube, meter cube, or whatever cube it is, temperature is also measured in both Celsius and Kelvin. And for you to be able to convert your temperature to Kelvin, you need the use of 273 degrees Celsius. As we're going to the class, we'll understand more about this. Number 1 question talks about the Charles law. So we have to use the Charles law in solving it. We'll be given our V1. Our V1 is 400 centimeter cube. The T1 we're given 30 degrees Celsius, and because it is very constant and Kelvin is the only unit being used in some of these gas laws, I have to add 273 to give me my Kelvin, and therefore I should have 30 plus 273 to give me 303 Kelvin. Yes. So my T2, I was given T2 50 degrees Celsius. The same way I converted this to Kelvin, I also convert this by adding 273, so I should have 323 Kelvin, while my V2 is unknown. Using the formula V1 over T1 is equal to V2 over T2, I should therefore have 400 over T1 303 will give me V2 over 323. Let's multiply and divide. By the time we're done dividing, multiplicating, we should have 426.40 centimeter cube. That is the answer for number 1. So number 2, a certain gas occupied at volume of 35 centimeter cube at minus 20 degrees Celsius. What will be its temperature when its volume is 50 centimeter cube? Pressure is constant. We'll still need the Chancellor because everything I was given there is volume and temperature. So, my V1, the first volume I came across, is 35 centimeter cube. Right, the first volume I came across is minus 20. Converting it to Kelvin is possible. What you just need to do is 273 plus minus 20 will give me 253 Kelvin. So I've been able to convert it to Kelvin. My V2 is 50 centimeter cube, while my T2 is unknown. So using this formula, V1 over T1 is equal to V2 over T2. I should therefore have 35 over 253 should give me 50 all over T2 because I wasn't given. Multiplying everything, T2 should therefore give me 253 times 50 over 35. My T2 is therefore 12,650 over 35. My T2 is therefore 361.43 Kelvin. There are times when you'll also be asked to leave your temperature in Celsius. What do I need to do? You just need to subtract 273 from the main value you got. So if I'm to convert this to Celsius, I should therefore have 361.43 minus 273. And this should therefore give me 88.43 degrees Celsius. So that comes to the end of our class on gas law for today. I promise to bring in more questions on some other gas laws that we have in chemistry. But even before then, please subscribe, share this video, tell someone to tell someone that our Dawn online class on YouTube and on Facebook is ready to make math and chemistry very easy and full of fun. Till then, I love you guys.